Today we're going to learn about the current divider rule. The current divider rule is used to calculate the current flowing in any of the branches in a parallel circuit. So firstly, we'll look at a series circuit. If you look at a series circuit, the same current flows through all the components in the circuit. But in a parallel circuit, the source current is split between the branches. For example, in this case, IS is split into I1 and I2. So according to Kirchhoff's current law, we know that the sum of currents flowing into one node is equal to the sum of currents flowing out of that node. So in this circuit, the source current, that is IS, is equal to I1 plus I2. When it comes to a parallel circuit, the voltage across the components in parallel are the same. So in this case, V1 is equal to V2. The voltage across the resistor R1 is equal to the voltage across the resistor R2. So using Ohm's law, V equals IR, we can say I1 times R1 is equal to I2 times R2. Now we're going to derive the equation to find the current in each branch. So the first equation we're going to use is IS equals to I1 plus I2. And the second equation we're going to use is I1 times R1 equals to I2 times R2, which we found before. Then we have to make I2 the subject in equation 1. After that, we have to substitute I2 with IS minus I1 in equation 2. Then we get a third equation. We have to rearrange equation 3 to make I1 the subject. After rearranging equation 3, we get I1 equals to R2 over R1 plus R2 times IS. We can also solve for I2, where we get I2 equals to R1 over R1 plus R2 times IS. The only difference between the two equations is that I1 is proportional to R2 and I2 is proportional to R1.